An ordinary beam balance works by adjusting the amount of mass on one side of the beam so that its weight exactly balances the weight of a test mass on the other side. Gravitational force against gravitational force. A Watt balance, for all its sophistication, does basically the same thing. In this case, however, the force that balances the weight of the mass is not gravitational, but electromagnetic. This force is produced by a coil of wire that is suspended in a strong magnetic field, created by stationary permanent magnets. The Watt balance lets researchers determine the mass of an object indirectly by determining two quantities: the strength of the magnetic field and the current running through the coil of wire. It does this in two separate measuring modes. The first, called velocity mode, uses an electric motor to move the coil through the magnetic field at a constant velocity. This movement induces a voltage in the coil that is exactly proportional to the field strength. Measuring the voltage indicates the field strength. In the second mode, called weighing mode, an electrical current is run through the coil to turn it into an electromagnet. As the coil's field interacts with that of the permanent magnets, an upward force is exerted, proportional to the current, which can be measured. NIST's new Watt balance uses a wheel instead of a balance beam. Attached to the wheel on one side is the coil and a platform for the test mass. On the other side is the motor that moves the coil in velocity mode. Both the coil and the motor are surrounded by metal enclosures. In velocity mode, laser sensors track the coil's motion using a technique called interferometry. This detects differences in position as small as a fraction of the wavelength of the laser light. As the motor moves the coil, the interferometry system ensures that the coil's motion remains perfectly constant. That constant velocity makes it possible to calculate the strength of the magnetic field. In weighing mode, a test mass is placed onto the platform on the same side of the balance as the coil. An electrical current runs through the coil, producing an upward force that is proportional to the current. By carefully adjusting the current, the upward force is tuned until it exactly offsets the weight of the test mass, and the system reaches equilibrium.